Dark matter is one of the most mysterious substances in the universe. Although it does not emit light or interact with electromagnetic radiation, astronomers are confident in its existence because it affects the motion of galaxies. Without dark matter, galaxies simply would not be able to hold their stars, because the mass that we can observe is not enough to do this. Dark matter makes up about 27% of the mass and energy of the entire universe, while ordinary matter makes up only 5%. Galaxies collide, and that's okay. Although space seems empty, galaxies regularly collide with each other. For example, the Milky Way is moving toward Andromeda at 110 kilometers per second, and in 4 billion years they will merge into one giant elliptical galaxy. During such collisions, stars almost never collide. The distance between them is too great, but gravitational forces completely change the structure of galaxies and can trigger bursts of star formation. Space-time flows differently. Due to Einstein's theory of relativity, time flows unevenly in space. The closer an object is to a strong source of gravity, such as a black hole, the slower time flows. This means that for an astronaut near a black hole, only a few hours will pass, while on Earth, years will pass. This is not science fiction, but a proven scientific fact, confirmed by observations and experiments. Space smells. Astronauts returning from spacewalks describe a smell that lingers on their spacesuits. It resembles the smell of welding metal, burnt meat, or ozone. Scientists speculate that it is due to high-energy particles that interact with the equipment, leaving a unique aroma. Vacuum doesn't kill instantly. Contrary to popular myths, you don't die instantly in outer space without a spacesuit. You lose consciousness within 15 seconds due to lack of oxygen, but death occurs within about 90 seconds. The pressure in a vacuum causes the fluids in your body to boil, but your skin keeps everything in. There is even one case of a person surviving brief exposure to a vacuum during NASA testing. Neutron stars are superdense monsters. Neutron stars are the remnants of supernova explosions. They weigh more than the sun but are only 20 kilometers in diameter. A tablespoon of material from a neutron star would weigh about 1 billion tons. They also have an extremely powerful magnetic field that can destroy electronics and even affect molecules kilometers away. Space is expanding faster and faster. It was previously believed that the expansion of the universe was slowing down, but in 1998 it was discovered that it was actually accelerating. This discovery shocked scientists and led to the concept of dark energy, which is believed to fill space and push objects away from each other. The nature of this energy remains a mystery to this day. Black holes evaporate. Stephen Hawking proved that black holes emit energy called Hawking radiation. This means that they can slowly lose mass and eventually disappear. Small black holes evaporate faster than large ones, but the entire process takes billions of years. The universe has sounds. While sound doesn't travel in a vacuum, scientists have translated vibrations detected in galaxies and nebulae into sound waves. For example, in 2022, NASA released the sound of the black hole at the center of the Perseus cluster, a low, ominous hum that sounds like the soundtrack to a horror movie. The universe may be infinite or a loop. The shape of the universe is one of the most fundamental mysteries. There is a hypothesis that the universe may be looped like the surface of a torus, where if you fly long enough, you will return to the same point. There is also a theory of multi-dimensional spaces, where our universe is just a bubble in a large multiverse ocean. Red dwarfs may be a, quote, safe haven for life. Red dwarfs are the most common stars in the universe, making up about 70% of all stars. Although they are smaller and cooler than the sun, they live for tens or even hundreds of billions of years, giving time for life to develop. Planets in the habitable zone of a red dwarf are very close to their star, and one side of such planets may be in perpetual day, while the other side is in perpetual night. However, in between them there may be a twilight zone, where moderate conditions are possible. Space is cold, but not everywhere. The average temperature of interstellar space is about -270 degrees Celsius, just above absolute zero. However, there are places where it can be hotter than the surface of the sun. For example, the sun's corona, the outer atmosphere, has a temperature of about 1–2 million degrees, which is paradoxical, since it is further from the core. The reason is still not entirely clear, and is one of the mysteries of solar physics. Stars sing, stars vibrate, and these vibrations can be interpreted as sounds. Using asteroseismology, scientists listen to stars and study their internal structure, just as seismologists study the Earth's interior. For example, the sun vibrates with millions of sound waves passing through it. We don't hear them directly, but we can translate this data into sound. Venus can have acid rain, and it evaporates before it reaches the ground. Venus's atmosphere is mostly carbon dioxide, and its clouds contain sulfuric acid. At an altitude of about 50 kilometers, sulfuric acid rains form, but they evaporate before they reach the surface due to the monstrous temperature, over 460 degrees Celsius. The surface of Venus is one of the most hellish places in the solar system. The universe saw the light only after 380,000 years. Immediately after the Big Bang, the universe was an opaque, hot plasma fog. Light could not pass through because photons were constantly colliding with particles. Only after 380,000 years did the temperature drop so much that electrons and protons formed atoms, and the universe became transparent. It was at this point that we now observe the cosmic microwave background radiation. Cosmic rays, a danger from the deep universe. Cosmic rays are super-energetic particles that can pass through metal, concrete, and even the human body. They can damage DNA and go beyond the protection provided by Earth's magnetosphere. Radiation levels in space are one of the main concerns for future missions to Mars and beyond.